Welcome back to the session on interpolation. In the previous session, we derived Newton's forward interpolation formula. Now, in this session, here we shall derive Newton's backward difference formula. Let y equal to f of x be a function which takes values y0, y1, y2, etc. yn at equally spaced points x0, x1, x2, etc. xn. That is, xr is equal to x0 plus r into h, where r varies from 0 on to 3 up to n. H is the interval of differencing. Let phi of x be a polynomial of nth degree in x, taking the same values as y corresponding to these values of x, that is x0, x1, etc. xn. Then phi of x represents y equal to f of x such that f of xr is equal to phi of xr, for r varies from 0, 1, 2, 3 up to n. We may write f of x as f of x is approximately equal to phi of x, which is equal to a0 plus a1 into x minus xn plus a2 into x minus xn into x minus xn minus 1 plus etc. plus an into x minus xn into x minus xn minus 1 into x minus xn minus 2 into etc. x minus x2 into x minus x1. If we put x equal to xn, we have f of xn is equal to a0. All the terms contains x minus xn, therefore, all the terms will become 0. F of xn means yn, that is yn is equal to a0, or a0 is equal to yn. The constant a0 is yn. Putting x equal to xn minus 1, we get f of xn minus 1 is equal to a0 plus a1 into xn minus 1 minus xn. All the other terms contain the term x minus xn minus 1. If we put x equal to xn minus 1, all the terms will become 0. That is, f of x n minus 1 is y n minus 1. This gives, this is equal to, this gives y n minus 1 is equal to a0 is yn plus a1 into xn minus 1 minus xn can be taken as minus h, because xn minus xn minus 1 is h, therefore, xn minus 1 minus xn is minus h. That is, yn minus 1 minus yn is equal to a1 into minus h, or yn minus y n minus 1 divided by h is equal to a 1. That is a 1 is equal to y n minus 1 divided by h. But y n minus 1 is the backward difference del y n divided by h, which is a 1. This can be written as del y n divided by 1 factorial into h. Similarly, if we put x equal to x n minus 2, we get f of x n minus 2 as a naught plus a naught is y n plus a 1 is del y n divided by 1 factorial into h, x n minus 2 minus x n plus a 2 into x n minus 2 minus x n into x n minus 2 minus x n minus 1. That is f of x n minus 2 is y n minus 2, which is equal to y n plus del y n divided by 1 factorial into h. X n minus 2 minus x n can be written as x n minus 2 minus x n minus 1 plus x n minus 1 minus x n. We just add x n minus 1 and subtract the same, plus a 2 into, like this, here we can write x n minus 2 minus x n minus 1 plus x n minus 1 minus x n into x n minus 2 minus x n minus 1. This is equal to y n plus del y n divided by 1 factorial into h into this is h plus h, sorry, this is minus h plus a 2 into x n minus 2 minus x n minus 1 is minus h plus this also minus h into this is minus h. That is equal to y n plus del y n divided by 1 factorial. Here minus h plus minus h is minus 2 times h, therefore h and h cancelled. This is minus 2 plus a 2 into here minus 2 h into minus h is plus 2 h square. Here y n minus 2 equal to this. That is y n minus 2 is equal to y n minus 2 times y n plus y 2 times y n minus 1. By the definition of del, right, del y n equal to y n minus 1 minus y n. We multiply by minus 2 plus a 2 into 2 h square or 2 h square a 2. From this we can write a 2 as a 2 is equal to y n minus 2 times y n minus 1 plus y n minus 2 all divided by 2 h square. This is by definition of del. This is del square. Definition of del square is del square y n divided by 2 h square. 2 means 2 factorial into h square. Similarly, by putting x equal to x n minus 3, x equal to x n minus 4, etc., we get a 3 as a 3 equal to del cube yn divided by 3 factorial into h cube, a4 is equal to del raised to 4 yn divided by 4 factorial into h raised to 4, etc. In general, an as an equal to del raised to n yn divided by n factorial into h raised to n. Substituting these coefficients in this expression for f of x, we get f of x as f of x is equal to a naught is yn plus a1 is del yn divided by 1 factorial into h into x minus xn plus a2 is del square yn divided by 2 factorial into h square x minus xn into x minus xn minus 1 plus etc. In general, del raised to n yn divided by n factorial into h raised to n x minus xn into x minus xn minus 1 etc. x minus x1. If we set u as u equal to x minus xn divided by h, we get x minus xn is equal to uh. X minus xn minus 1 can be written as x minus xn plus xn minus xn minus 1, that is just add xn and subtract the same. This is equal to x minus xn is uh, xn minus xn minus 1 is h, that is equal to plus h is u plus 1 into h. Similarly, x minus xn minus 2 can be written as u plus 2 into h, etc. X minus x1 can be written as u plus n minus 1 into h, u plus n minus 1 into h. This is x minus x1. Therefore, this expression will become f of x is equal to yn plus x minus xn is divided by h means h and h cancelled, that is u by 1 factorial into del yn plus here x minus xn is x minus xn minus 1 is u plus 1 times h into h is h square and this h square will be cancelled. We get u into u plus 1 divided by 2 factorial into del square yn plus etc. In general, u into u plus 1 u into u plus 2 etc. u plus n minus 1 divided by n factorial into del raised to n yn. This formula is known as Newton's backward interpolation formula. This Newton's backward interpolation formula can be used to interpolate the value of y or the value of f of x in the end of a given data. For an example, evaluate f of 7.5. We have to evaluate f of 7.5 for the given data. The data is the values of x are 1, 2, 3 up to 8. The y values are 1, 8, y values are 1, 8, 27, 64, 125, 216, 343 and 512. We have to evaluate f of 7.5. Here f of 7.5 is in between 7 and 8, which is at the end of this given data. 7.5 is at the end of the given data. Therefore, we use the backward interpolation formula. First of all, we have to construct the difference table. The first differences are 7, 8 minus 1 is 7. This is 27 minus 8 is 19, 37, 61, 91. 343 minus 250, 216. 343 minus 216 is 127. This is 169. These are the first differences. The second differences are 12, 18, 24, 30, 36, and 42. The third differences are 6, 6, 6, 6, 6, all are 6, and the fourth differences and the fifth differences are 0. And all the other differences are 0. Here we have xn is equal to, the last value is 8, x equal to 7.5, the value of x at which the function is to be evaluated, that is x equal to 7.5. Interval of differencing is 2 minus 1, 3 minus 2, that is h equal to 1. Therefore, u equal to x minus xn divided by h, that is 7.5 minus 8 means negative 0.5, h equal to minus 0.5, sorry, u equal to minus 0.5, this is negative. Now, by the Newton's backward interpolation formula, we have f of x equal to y n plus u by 1 factorial into del y n and so on. We put x equal to 7.5, we will get f of 7.5 as y n is 512 plus u is minus 0.5 divided by 1 factorial into del y n is this is del y n, that is into 169 plus u into u plus 1, that is minus 0.5 into minus 0.5 plus 1 divided by 2 factorial into del square y n is this 42 plus next is minus 0.5 into minus 0.5 plus 1 into minus 0.5 plus 2 divided by 3 factorial into next difference is this 6 and all the other differences are 0. Therefore, the remaining term will become 0. On simplification, we will get f of 7.5 as f of 7.5 is equal to 421.87. That is, we obtained the value of f of 7.5 by using the Newton's backward interpolation formula. The Newton's backward interpolation formula can be used to find the polynomial function corresponding to a given data. For example, if the given data is the x values are 0, 1, 2, 3 and the corresponding y values are 1, 2, 1 and 10, then we can find the corresponding cubic polynomial by using the Newton's backward interpolation formula. First of all, we have to construct the difference table. The first differences are 2 minus 1 is 1, this is minus 1, here 9. Second differences are minus 1 is minus 2, 9 minus minus 1 is 9 plus 1, 10. The third differences are del cube y, that is 10 minus minus 2 is 12. This is the difference table. By Newton's backward interpolation formula, we have y equal to y naught plus u by 1 factorial into del y n plus u into u plus 1 by 2 factorial into del square y n plus etc. plus u into u plus 1 into u plus 2 into etc. u plus n minus 1 divided by n factorial into del raised to n y n. Here x n is equal to 3, interval of differencing h is 1. Therefore, u equal to x minus x n divided by h is 1. Therefore, that is u equal to x minus 3. Therefore, this will become y naught is here y n is 10, this is y n plus u is x minus 3 divided by 1 factorial into this is del y n, that is into 9 plus here x minus 3 into u plus 1 means x minus 3 plus 1, that is x minus 2 divided by 2 factorial into del square y n is 10. The next term is x minus 3, that is u into u plus 1 into u plus 2, that is x minus 3 into x minus 2 into x minus 1 divided by 3 factorial into del cube y n is this, that is into 12. On simplification, we will get y of x or f of x as y of x is equal to 2x cube minus 7x square plus 6x plus 1. This is the required cubic polynomial corresponding to this given data. Let me conclude this session. In this session, we derived the Newton's backward interpolation formula, and we observed that the Newton's backward interpolation formula can be used to interpolate a value of y at the end of a given data, and which can be used to find out a corresponding polynomial of the given data. Thank you for watching this session, and we can meet again in the next session. Have a nice day.